to me then about the artificial intelligence and, if you like, the front line, the exciting bits for you right now in terms of how it is changing the landscape of your work.
So artificial intelligence, many might be familiar with, certainly the artificial intelligence that we all interact with most typically day to day, in the way that we, the way that we text and on images and things, those are capabilities that we have not traditionally used in nuclear proliferation detection, and allow us to interact with different ways to observe the world than we have traditionally done in proliferation detection. And one thing that you get with artificial intelligence is the ability to interact with that data at an entirely new scale. And in proliferation detection, we are looking for really, really subtle clues. And I think everyone can appreciate that you increase the likelihood that you're going to come against one of those subtle clues if you can increase your ability to observe. So in that way, artificial intelligence gives us entirely new data sources, new ways to observe the world, new ways to find these subtle clues that are indicative of nuclear proliferation. And because we're not only looking for chemistry signatures, there's a possibility that we might discover a clue that has to do with nuclear program development, but that isn't, necessarily tied to this chemical, the chemistry of material development.
Can you give some examples? I mean, this is a type of pattern recognition you're describing, essentially, isn't it? That you are going to spot clues by associating disparate pieces of data that will flag up a red flag. Show me, describe, give me an example. I mean, I don't, obviously without giving away state secrets.
Yeah, so we've always it's more than hypothesized, but we've always understood, I think everyone can kind of understand that there would be indicators of nuclear weapons development, or particularly as we move towards intent in the development or acquisition of specialized materials, specialized expertise, specialized technologies, or even technologies that are dual use, that could be used illicitly for nuclear weapons development, or perhaps could be used for civilian applications. And some of those things are observable in different data sources. And so we have been able to use AI again to look at big data, look for these patterns in big data, watch them over time, and to observe the development or the acquisition of specialized skills, of specialized expertise, the amassing of specialized technologies, and kind of to your point of amassing disparate pieces of information. Sometimes, we're looking at different combinations of things, computationally enumerating multiple hypotheses that allow us to kind of play with, does this combination of expertise that we see somebody acquiring, is that threatening, is that risky? But do all of that computationally and do it at scale in the artificial intelligence system, which allows us to pull many more threads than you could do that if you were just, like we're doing kind of automatically based on our intuition, but do it at an entirely new scale that presents a powerful capability for nuclear nonproliferation.
I'm going to throw in a really dumb example. Does that mean if there was a high intensity of Google searches for particle accelerators in the Natanz region of central Iran, that you would, it might raise a red flag? In other words, you could be pulling in how people are using the web, maybe in one area, but also, I don't know, as you say, import metrics of certain types of tubing coming into that country at the same time. And so you would be cross-referencing those two data sets.
Those elements of information that you just described are certainly the sorts of things that we want to be able to combine in an artificial intelligence capability.
So, I mean, how does this apply? I'm curious. There was a story, wasn't there? This is in the context of the Ukraine invasion, that there were worries by probably totally spurious on the part of the Russians that Ukraine would be developing or redeveloping, reacquiring nuclear weapons. There is no chance, is there, that a country like Ukraine, obviously it was a formerly housed Soviet, parts of the Soviet arsenal, they gave them up after the end of the Soviet Union, that country could reacquire using existing knowledge without anyone noticing. I mean, it would be a very high profile event in the event of a country of that size gaining. It would be a long process.
I mean, I can't really speak to that specific example exactly, but you know, we do as scholars of nuclear nonproliferation try to seek to understand historical examples, and also, you know, understanding the context, what might motivate one to pursue nuclear weapons or not. And that same sort of analysis would apply to Ukraine.
So talk to me then about the AI in more detail. Are there particular developers of AI? Is this AI that's come from the private sector that you are developing or that you are responding to? Are you working in harness with the private sector?
We work as closely as we can with the private sector, leveraging billions of dollars of investment and powerful capabilities coming from private industry and artificial intelligence, particularly like in the modalities that we're all most familiar with, images and text. But the nature of the problems that we face means that in many cases, we have to develop really new techniques for training, new model architectures that are better suited for our problems, or even in some cases work at all. And in that case, most of our research is done at the Department of Energy National Laboratories to advance the science of AI and build new capabilities suitable for the challenging operational conditions and high consequence missions of national security. And some of this is to overcome issues of data sparsity. You know, if you're familiar with sort of the way we think of AI and big data, the sort of data space that we have in national security and nuclear nonproliferation looks very different than the big data of Google and Facebook. And so the models that we use, the approaches that we use to build these models has to be different as well. And in that, we're finding all sorts of very interesting and very powerful ways to build AI that I do think are broadly applicable to other domains, even outside national security. And I kind of also think is the future of artificial intelligence. These new ways to solve problems that are harder to solve than well, I don't want to irritate anyone in picking what problem is harder or not. But nonetheless, I'll just suffice it to say, we can't just collect more data. You know, you can't just ask so-and-so adversary to give you more data and tell you exactly when you got the problem right. You know, we face a really challenging environment and an adversary who does not want us to succeed. And that demands
and I mean, you've got to prove that you're right. That's an interesting element of this, isn't it? I mean, any normal challenge in a scientific context is, you know, you test your results against the evidence. But you can't really test this if a secretive foreign power is not divulging what you allege to be true and you suspect to be true, but you cannot, you can't double down on what it is you've produced. So how do you test the AI in that context?
You know, there are a number. It's a silly way to answer. It depends. So I'll just speak to a couple ways that we have. You know, certainly you get as close as you can to elements of scenarios that you think are happening and try to prove those. One way that we prove those is the National Nuclear Security Administration runs a network of test beds in which we can mock up scenarios and generate some data that looks similar to a real world threat, something. And we challenge our algorithms against that. But even still, you know, that's not exactly the same as using your algorithm against an adversary. So the more promising technique that I'm actually more excited about are when you build the model, never thinking that you're going to actually know the target environment very well. And a lot of techniques, like you asked earlier about what we have used historically, a lot of the techniques that we've used historically and the technologies require that you calibrate. You know, everyone's kind of familiar with calibration. You calibrate for the real world target environment. We're developing AI that does not require calibration. It kind of always assumes it's in a hostile environment and is self-calibrating. And we've been able to accomplish that by developing or by generating really, really carefully constructed training data sets that aren't necessarily representative of the real world, but that allow us to train a self-calibrating algorithm that performs predictably, maybe not the best, but still performs in a way that is good enough, even in an uncharacterized environment that we've not had a chance to calibrate to. So those are some ways that we are overcoming them, but you've tapped this very real aspect to developing technology and solutions and national security, is that you're never exactly going to be able to test it. We test it in the exact way. So we have to build in some fail safes. We have to build in transparency so that it's still useful for national security analysts and decision makers.
Do you create your own dummy tests at home, like kind of, I don't know, mock up a false hostile environment using whatever data sets you have to in other words, to stress test your own tech?
Yeah, I love that you said whatever data we have. I say you go to war with the data you have. You have what you have, and you have to make exceptionally good use of that. In some aspects of nuclear nonproliferation, we also have an advantage in that chemistry is well characterized with computational chemistry models. There are some aspects of physics and nuclear engineering that are well characterized with predictive models. And so we're also developing techniques that combine predictive, and I should say the national laboratories have long-standing capability in these areas, but we kind of know where we've plateaued with that capability. So we're also developing techniques that combine computational models, combine data-driven and exploratory models and artificial intelligence to create this Frankenstein computational capability that gets you a little bit of the best of the both worlds, and is another way of filling in those spaces that you may not have data for, or where you're making a guess about what the adversary might be doing. I see a nuke GANs in there. GANs is an interesting technique to use for this, but not the only technique we use all the time, but nuke GANs is a fun way to think of it.
Right, yeah. Mark is jumping in to observe. This is Mark Anderson to observe that we will be talking about pattern computing tomorrow, which of course is another form of, the front end, if you like, of a private sector initiative to mobilize the power of AI in all kinds of other different settings. Specifically then, obviously much of AI, the front end of it, we think of, I mean, perhaps it occurs to many people in the context of autonomous vehicles. We're looking at the way in which imagery cameras can detect and understand imagery. Now, obviously satellite imagery, I'm sure, plays a big part in the data sets that you're using. Is that part of what we're describing here?
Yeah, absolutely. Any and all data will find a home in the sorts of techniques that we're developing. I will say, so sometimes we're talking about AI as a distinct analytical capability against a single data set. That's understanding AI as a model, a combination of compute and data and algorithm. And certainly we're developing artificial intelligence to better exploit data sets like imagery, display sensor data sets like waveform data and spectral data, unstructured data sets also. But sometimes we're talking about artificial intelligence as this computational framework with which to fuse data. And in that, we're also looking at image data and combining it with lots of other data sources. Image and text is something that we can look to industry for having done. But there's an interesting aspect to images and text that is another place where we see the distinction in the work that we do. Image and text, even sort of the imagery of self-driving cars and overhead imagery, are a self-explanatory data source. Anybody can interpret what's happening in an image or a text data. But for some of our other data sources, seismic data, radiation detection data, other chemistry data that we're looking at, some of these data sources require heavy pre-processing, signal processing, PhD level stuff, even to get to where you can begin to interpret data. And that presents, really different workflows for interacting with it as an artificial intelligence scientist, kind of brings an entirely different disciplines that we need to work with. And when you think about fusing those data sources, tons of different, data fusion is like a combinatorics thing as much as anything else. So hopefully, I just meant to say, you can, I think, begin to appreciate the complexity of this, especially when you incorporate some of these other data sources that are not as self-explanatory as something like an image or a text data.
You work in the Department of Energy. To what extent are you, or is your research being mobilized by the wider, defense effort? I mean, is it being incorporated into new, I don't know, weaponry or battlefield tools?
Well, we do work closely with agency partners around the national security enterprise and kind of even more broadly, and hope that they'll leverage the research investments that we make wherever possible. I can't speak to the specifics, but even if they are using the specific models that we are developing and the techniques that we're developing, like as I described, to ensure that your model is robust for challenging environments, performs predictably when it meets unexpected data, that will enhance the robustness of any artificial intelligence algorithm. So it is our charter to work closely with the Department of Defense, Department of Homeland Security, particularly in where they perform nuclear nonproliferation and counterproliferation roles. And then we do hope that the techniques that we're developing will become the standard practice for national security artificial intelligence, because they'll help you build better AI no matter what your application is.
You are cherry picking from private sector, if you can, obviously, if they'll let you. And are they cherry picking from you? I mean, is there a kind of cross fertilization there?
That's another place where I hope so. Again, for some of our use cases, the business cases for the private sector may not be immediately visible, but I do think that these are the techniques that will help us overcome. We're going to find a plateau with AI. Well, not in every place, but there will be plateaus where we will need new techniques to begin to expand the application of artificial intelligence, even for commercial applications. And in those places, I hope that commercial industry will also leverage what we're doing. Under the nature of our work, we publish very openly to the extent that we can, in the hopes that others will leverage our work, whether it's for commercial applications or national security applications. In that case, we're not talking about giving anybody state secrets there either. But where we've learned something about the future of artificial intelligence, I'll also say sometimes I hope to get the private sector and the academic community excited about the problems that we face in national security, so they will be motivated to contribute. Because there are, of course, powerful, talented researchers in the private sector and in academia, and we would love to mobilize their brains, to help us overcome the challenges of AI in this space.
You talk about the future of AI, and we have, of course, talked also about the problems of provability when you come up with diagnoses around a particular state. Is there a black box risk here? The kind we famously was example given, wasn't it, in the way that sentencing was being used, wasn't it, by some judges in the US? It became a bit of a cause célèbre because certain people were being sent to prison, and essentially it was because the AI was instructing judges based on their past record that proved to be racially prejudicial in some cases, for example, and in other ways. Now, is there a risk that AI could here be doing something in a very different context, doing something similar to determine and to misdiagnose? I mean, is that a concern that the AI actually gets ahead of the kind of the common sense, as you say, academic diagnoses that would apply to any previous data set in previous generations?
That's always a risk. To not recognize that risk would almost doom you to do it, but I always kind of push back about the thinking about AI as a black box, because I think it sets us up for a little bit of laziness in our understanding of problem solving if you're building one of these AI systems. The thing that's artificial about artificial intelligence is not the intelligence part, it's the artificial part, the part that is technology and computer. There's still a sense of a law of conservation of information within an artificial intelligence system. It's not going to be able to create new information of nothing. And similarly, if you introduce biases into it based on our own biases, our own lack of information, it will repeat those same things. And of course, that's what happens. Is what has happened in those cases. And so we manage that risk in our pursuit of artificial intelligence for the missions that we go after to the extent that we can. There are mathematical techniques and I don't want to say philosophical, but kind of procedures to follow to manage the risk of that and to limit the negative potential consequences from that. That is another place where other fields are bound by ethics. That is a place where we can lean into the scientific underpinnings, the laws of physics that underpin some aspects of nuclear nonproliferation. But as we've said, as we move more into intent, we're not bound as much by the laws of physics as other things. One thing I will say as to my personal approach to artificial intelligence is that I'm a Black woman, and I know, especially in national security, I am not in data. I'm such a kind of statistically insignificant data element that you can't even see me if you look at the data. And in that way, I'm kind of similar to the things that we're looking for in nuclear proliferation detection, these really important but statistically insignificant things that are hard to see. And that understanding of data and reality has informed the way that I have guided the development of artificial intelligence in this program. So we have never been so governed by data as some other pursuits of artificial intelligence and other programs that we would fail to acknowledge the shortcoming of data. We are grounded as much as we can to the truth of the system and understand that data will never be exactly correct to that. And so we've always been trying to overcome that in the way that we develop data, in a way that I think gave us a little bit of a head start in appreciating that shortcoming and advance in developing capabilities to overcome it.
Obviously, your main aim here is to produce something predictive, right? Something that, well, I mean, maybe it's not the main aim, but you're producing something predictive that will signal in advance, an early warning system that will work better than others has done in the past to tell us who is doing what out there. Are you retrospectively pulling together data? I mean, I'm thinking it could be almost anything. If you were to look at the public statements of Pakistan when it was trying to develop its nuclear weapons, or South Africa or somewhere, one of these countries, would you actually literally go into the historical record and start looking at how those countries behaved, how they started behaving abnormally, perhaps, prior to their nuclear programs developing?
Absolutely. And that's a great place where we also leverage work done at universities. There are a lot of universities that do this historical retrospective investigation. And that is an approach that we apply, even, as of today, the future is still, but we can still kind of, anyway. But one thing I was getting a little excited about that too, is that, artificial intelligence isn't just about the deep learning model. As we become organizations that are, ready for and enabled by artificial intelligence, it brings with it other disciplines like better IT, information technology systems, better data engineering and management practices. And so even though, we're talking largely about AI, and maybe everybody appreciates this, but with this comes these peripheral capabilities and infrastructures like data engineering and better data management. And so we're instituting these, as you can expect, as well, as we're developing artificial intelligence. And so one thing I'm also excited about is that, maybe this sounds really nerdy, but hopefully there are some data engineering folks in this meeting. But, as you implement these data engineering practices that allow you to better take advantage of your data, that means that, with every day, it means that we're setting up a capability where even something that we're looking at now, or even if we apply this, like you said, to historical examples, we can look over a longer array of time period, look at signatures over a longer time period. And one thing I hope this will allow us to do, and that we have done successfully in some cases, is maybe we know something is true at today, but we have the data infrastructure to go back and look historically or even in near history. In that way, sometimes we're able to back up the signatures that we're discovering to push ourselves earlier. So maybe in the research that we're doing, we're looking in real time, but that allows us to develop a signature that, even though we learned it today based on a now event or kind of learned it looking historically, it allows us to find like a token signature between a real world event that happened and then look back in that data and find an early indicator. And so that is another way, through applying better data management practices and looking historically at the data, that we're able to both, learn generally signatures, but also find these connected early indicators that would have enabled us to know more about the truth that happened, but earlier in time.
Angela, don't apologize for being nerdy. You're at fire. It's you've come to the right place. It's a hotbed, and it's wonderful to have you here answering so many of these detailed questions. This is a question, actually, and I'm going to slightly steal Berit's job here because it's been fired out. When will AI tell you what data you are missing from your data set? Or will it?
Yeah, certainly that is depending on the kind of question that you're asking the AI and the way that you set up the query system. And I'm really here not talking about, you can't do this with like a classification task specifically, but in some cases you can do that now. Especially we're developing some dynamic information fusion systems where not only are you telling not only can you from this system, it will put information together and perhaps give you an answer or something, category of answer. You can also kind of flip this system to tell you what piece of information you would need next, or what would be the next best piece of information that you would need, a value of information type assessment. A lot of that comes with optimization models. It's sort of a built-in capability. So in some cases we can do that now. And I do think, as we open our minds to the use of architectures and frameworks like that as artificial intelligence, free ourselves from just deep learning based artificial intelligence, for example, we'll begin to appreciate that you get that more often. But we're not, so that's kind of a niche answer. I don't mean to be cute with that answer. In some cases, if you're doing it a particular way, you can have it now. But that means it could be kind of any time that we can begin to, AI is what you make of it. So sometimes we don't make AI do that because it is a little bit more challenging and more costly, that means, and perhaps for the private sector, there's not money to be made in that question. But we have those exact questions that Berit just posed. So we are building AI to answer those questions in that way.
Yeah, that was Kai Dalton. I'm sorry, I mentioned Berit. It wasn't Berit's question. Berit will be jumping in shortly, I believe, to bring other questions.
Yes, from we have about 10 minutes until Q&A is supposed to start, so you're still good.
Okay,
plenty
good,
of time.
Yeah.
Plenty of time.
So just going on, Angela, with the question, I put to you when we were chatting before the meeting, we were talking about some of the areas of course, AI and defense spending, and people talk a lot, don't they? And it's a media buzzword to talk about robot wars and things like this. This idea of machinery or technology that could select and indeed attack targets without the use of human intervention at all. Which is a step beyond what we have seen typically in the battlefield up to this point. There were a lot of independently or remote controlled weapons, but not fully autonomous in terms of selecting targets. None of this, of course, is directly the area you're fitting into, but are you finding that is an area where the Department of Defense is interested in the type of technology you're working?
So I can't speak to what the Department of Defense is interested in, but we certainly think of some of the same things in the nuclear non-proliferation space and within Department of Energy and among those agency partners as we think of nuclear non-proliferation and counter-proliferation. And we are very thoughtful about our sense of where or where independence of operation or allowing, okay, we'll just say, allowing AI to make a decision is appropriate. And I think that will be something that we continue to explore across the government and in collaboration with ethicists and other thinkers outside the government. It certainly is not obvious what the answer will be, I don't think yet, but I'll say we are very thoughtful about it, even in the counterproliferation space.
You talked about your excitement around the AI you're developing, and indeed how you think some of this is transformative and the most exciting in the field of AI, which, as you suggested, could be controversial given some of the people listening in. But I mean, tell me what you mean by that. Where do you see the low-hanging fruit or the most exciting areas of development, and where you think it could be applied more widely in, I don't know, in society at large, in the consumer sphere, wherever?
So this is a little non-technical and non-specific, but we have found, proliferation detection is narrow and narrowly confined. And well, one thing is exciting is that it infuses an entirely different, an entirely new capability into how we do it. Like we said, we've traditionally relied on, and we'll always rely on this particular approach, but artificial intelligence puts at our grasp an entirely new capability that I do think, we can seize on to help us reduce the global threat of nuclear weapons. And in similar ways, artificial intelligence will enable us to, I don't want to say attack, because we're not always talking about attack, but to go after really challenging problems that we've not been able to solve as a human race before. But some of this technology, it's not just going to be characterizing cat videos or even translating, some of it is going to be in these under-resourced areas of research, where there's not a lot of money to be made, where there's not a lot of data. And that's where we see the opportunity where in our going after these areas, we'll also develop capabilities to be leveraged to enhance the human experience and solve problems in other spaces. But I did want to say, if we really do seize on the promise of artificial intelligence, it has the potential, or we as humans have the potential to completely transform the way we think of solving problems if we can fully leverage artificial intelligence. And I'm not even talking about the stuff that we've done so far. What we've done so far is the low-hanging fruit. The real future is artificial intelligence means that, like when we're doing research right now, and this kind of speaks to Kai's question, when we're doing this applied research to figure out a new way to do proliferation detection, we still as humans are still setting up the experiments, still interpreting the results, kind of one iteration at a time. But what we imagine with artificial intelligence, and this is true for all aspects of discovery and sort of detection and information fusing, once we get artificial intelligence right, the AI will be setting up these experiments, and you'll do 100,000 experiments at once. And then the human will interpret the results of the 100,000 experiments instead of just interpreting the results of one experiment. And that's thinking on an entirely different dimension, thinking in an entirely different way than we do now. And like I just talked about research and discovery, there are the same capability can be applied for national security missions. So that really is the future. Computational science, big artificial intelligence and discovery, big brain human thinking, to just sort of blow up to a whole other dimension, our ability to discover, solve problems, and build solutions. And that's the hard stuff. What we're doing right now is the low-hanging fruit. AI right now is low-hanging fruit AI. This more exciting stuff is the future I just described.
Angela, that's terrific. I could carry on, but I think Berit, you can jump in now if you want. There's we've got 17 minutes left.
We have quite a lot of questions. So Shalab asked, what are some of those problems, the ones we haven't been able to tackle and which AI will allow us to tackle?
Put me on the spot. What are the problems we haven't been, like world hunger, poverty, in the national security, I mean, this earlier detection is a problem in nuclear non-proliferation we have not been able to tackle. And it will require some of this different thinking that I just described. You know, right now, it is standard tradecraft among whether you're doing something using technology or whether you're doing this sort of inspector, detective type work, whatever your approach is to solving a national security problem, we still think one dimension at a time. We can still only hold in our heads a limited number of hypotheses. The problems that we want to be able to solve with AI would be, for example, running tens of thousands of hypotheses about what's going on in Russia and Ukraine right now and assessing them constantly and developing or determining the best optimal or least terrible options in response to that. That sort of thinking, leveraging artificial intelligence, I think, is how we will tackle these unsolved problems in national security and the human experience.
Thanks, Angela. The next question comes from Mary Branscombe. Mary, do you want to unmute yourself? Sorry, I forgot to do that with. Otherwise, I will ask it on her behalf. She asked, is causal inference useful here? There are some great new tools for presenting those questions in business information and visualization systems.
Yeah, I'm not specifically familiar with the tools that they are describing, but well, I mean, yes, everything is useful here, but certainly also causal inference, prescription, some of the emerging techniques to get a little bit more out of your data and your artificial intelligence would absolutely be relevant.
Okay, and then Harsha Jawagal asks, considering the data is sparse and could well be imbalanced due to variability of data availability across different sources, there are high chances of false positives. How much do you rely on AI predicted result versus human conditioning?
I love this question. We think about this all the time. So like check, yep. Yeah, absolutely imbalanced. Imbalanced data means, and I tell this to people that are, and maybe there are people working in imbalanced data right now. Imbalanced data means that you're gonna have to do something with your deep learning approach, the training, so we're developing different approaches to the training steps, to the way that you curate the training data set to address and not to ignore. And actually, I'll step back in a sec. But anyway, to address these imbalances in the data, the likelihood of, I'm writing down false positives. One thing that is true in national security, so we are so starved for data and information. And in that data imbalance, there might be information that is actually useful in solving our problem. So we just try to squeeze all the information that we can out of every aspect. But kind of I think how that question ended, that also got me very excited. So we posed this exact question to human analysts who we work with when we build AI. Someone has to then go use this capability. And in one case, a group of human analysts reminded us that there are some cases where human analysts are very good at adjudicating false positives. In many analyst-heavy workflows, as in the standard practice in many national security missions right now, that's kind of what human analysts have been trained for decades. So there are some opportunities to allow what am I trying to say? To take on more false positives from the artificial intelligence and rely on the human analyst to adjudicate the false positives, because they're good at that, but it might be very expensive and you might lose too much information for the AI to do this. And this brings to mind a really powerful concept, which is human-centered artificial intelligence, or kind of design-centered thinking, and the human-machine teaming aspect of AI. And we often think of human-machine teaming as, I don't know, either user interface, or sometimes it's also like, just please get a human analyst to accept my tool, and that's hard enough. But really the way that I like to think of it, especially when we're thinking of the future, is that your artificial intelligence is a system. And at a minimum, it's a system between the human AI model, or the AI model, and the human. It's at a minimum a system of systems in that way. And so you should at a minimum be thinking of allocating data processing, compute, knowledge, algorithm between those two things, the human and the computer, to the best way possible. And in that there are some surprising allocations, some surprising outcomes. Sometimes you give the human part more data, sometimes less, but it is you have to think of it that way, and it's specific to the task you're asking the human computer system to do.
Robin Teagarden, are you here? Would you like to ask your question? I mean, I know you're here because you just asked it. Would you like to unmute and ask it yourself? So Bobbin is wondering, is there a way to have AI spawn many simultaneous quandaries and then merge and weight/sort the findings to get out of the single stream, then recurse as we do now, more like Hadoop? And Gary Marcus, I'm going to call on you next, so prepare to unmute yourself.
Yeah, there are certainly ways. Yes, I think we have pursued that sort of thing in different applications. There's never going to be one way to do this, and no matter which way no matter what you use, it's understanding that it is a estimation of reality, and so you want to use whatever is the best estimation for reality, and also understand what works and what doesn't work, and how the algorithm is sort of chugging through compute, and where your data limitations are, and all of that's another great technique that we have used. Though I will say, as we get better at this, I do think that in the future there will be a priori or sort of prescriptive practices for which thing is best to use in which case. Mm-hmm. One very emerging rule of thumb that we have determined is that when you're trying to overcome, when some of this sort of noise that we're thinking of is, I'm kind of thinking like Gaussian-ish, kind of described by that noise looks most like noise, that unpredictability of your system looks most like noise. GANs are a good approach to use. Some sort of AI generating technique is a good thing to use. But there are other cases where that unpredictability is described by something that you can represent with domain knowledge. In that case, we have found it better to use domain-informed designs for training data, for example. There are emerging techniques like that, as wherever we find them, I try to amplify them because they're going to be so important as we sort of carve out this future of AI space.
Thank you. Gary.
I seem to have just been drafted.
Yes, I've drafted you because I suspect that you know something about AI, and I saw you had a couple of comments, and I thought you might be interested to share them.
Sure. I come to AI from the cognitive sciences, trying to understand how humans think, and found an AI company that I sold to Uber, and put some references to some of my work in the chat. I'm very, very sympathetic to what Angela is saying. I think that we really need to move past deep learning. What I have argued for has 4 parts. One is neurosymbolic hybrids. The second is representation of large-scale knowledge. The third is having cognitive models of what's going on. And the fourth is reasoning about it. And a lot of what currently goes on is that systems try to do things end-to-end in a deep learning system. They need a massive amount of data, which, as Angela points out, doesn't apply to her problems and doesn't apply to lots of other problems like robotics or understanding language and domains where people haven't said a lot before and so forth. And I don't think we can solve those problems end-to-end based on large data that doesn't exist. I think even in domains where it does exist, we run into problems. So I think driving is very instructive. In driving, people have tried to solve it by scaling the amount of data and the size of models, and it hasn't worked so far. So we still have outlier problems, even in driving, where there's a massive, massive amount of data. And so I think it's time to ask, are we in a local minimum here? Yes, we get a little bit better at our large language models every week. So GPT-4 will be better than GPT-3. But the systems don't have enough deep comprehension of what's going on. They can't update models of the world, which is critical for intelligence kinds of applications. And so I think we really need to do something different. And I put in the chat references to my book, Rebooting AI, and an article called The Next Decade in AI, if people want to hear more about my spiel.
Thanks, Gary. I think Mark has one last question. Has a question. We have time for about one last question. So Mark, you want to unmute yourself?
Yeah, thank you. And thanks, Angela. This is terrific stuff. I think everybody here is very engaged. And I have 2 thoughts. One is, I think that Gary and I and many of the people here agree we need to go past neural networks. We all kind of are on that page. I think you are too. And so maybe we can chat later about that. But certainly there are a lot of people who would like to help you in what you're doing. And we would too. The other thought, a little more difficult. maybe there's an obvious answer here, but at SNS, we have been doing a lot of research on what we call CRINC, China, Russia, Iran, and North Korea. And we were early discoverers of missiles being sent secretly to North Korea by Iran. And we've talked to security people about this. And then one of the questions that remains for us is, there is a pattern broken where North Korea couldn't get over its own feet for a long time doing testing of nuclear weapons. They were not good at it. They were not good at building the weapons. They were too big. They didn't make enough progress. They blew themselves up. A lot of problems. And then suddenly, overnight, they became very good and very fast. And they reduced the size to fit on top of an ICBM and all kinds of great things if you're a North Korean. And it made me wonder, and I don't mean you should answer this in any way that is dangerous to our country, but it made me wonder if, in addition to receiving missiles from Iran, they were receiving nuclear blueprints or things to test from someone in CRINC, and that North Korea had become the playground for testing, even if others were prevented by treaty. And would you pick that up if that happened?
Well, I can't speak to that specifically, but I appreciate you bringing it up.
Good answer.
Thanks, Angela. We have one last question from Shalab. Shalab, are you ready to go?
Yes. I'm wondering, so I don't know how much you can get into this, but we kept coming back to the inputs and outputs of the algorithms you're working on, and I'm sure you're working on multiple different projects and multiple different algorithms with many different teams. But maybe if there is something you can talk about, I'm curious to know what specifically are you predicting? Because it seems like there's so many different things you can predict. And then what specifically are the inputs to these algorithms? What is actually being looked at in any, if you can talk about anything in that sense?
Yeah. So we have some algorithms that seek to enhance our ability to characterize whether a facility is being used for peaceful nuclear purposes or for illicit nuclear purposes. And some exciting work going on there is the fusion of different sensor data sources together to be able, so that you can get sort of you probably know the word digital twin. It's kind of making your own little ad hoc digital twin to be able to characterize what's going on. And to do so with under different operation scenarios. Perhaps you want to be able to monitor this facility remotely from outside a fence line. Perhaps you have access under a safeguards agreement to go into the fence and lay down a suite of sensors and characterize them the way that you want, with the goal of understanding, is anything being diverted from this research reactor, for illicit purposes. And then similarly, we kind of building around that idea of characterizing this facility. You can imagine using other sorts of data sources that look at other ins and outs, the movement of people around that facility. Can you tell, or could you imagine a program in which someone could say, well, I'm going to check the facility this many times, and if you can verify that I check it this many times in these ways, I'm only using it for peaceful purposes. Perhaps you can do that by looking at my entry and exit. Perhaps you can do that by some other way that I'm telling you that I'm at the facility or not. And so, some of it is the sorts of things that you would imagine, but to your point about the sorts of questions that we're asking, some of them are technical solutions. I don't mean technical. I mean, some things are related to the nuclear engineering, and some things are more related to illicit activity versus benign activity.
That digital twin thing is really interesting because you're kind of doing online model diagnosis, because you're creating, you create a model of the facility, assuming it's doing what you think it's doing. And then if the sensors give you something that it's, different than what you're predicting, basically with that digital twin, then, maybe something's wrong. That's very interesting. Thank you.
Yeah.
Angela, Shalab, I suggest that you two connect through our private video chat system. We're gonna have to wrap this up.
Thank you, Barrett. Thank you, Ed.
Thank you, Angela. Fantastic conversation. And thank you, Ed.
Thank you.